Everyone okay today? Y'all doing all right? I felt terrible yesterday. I'm a little better today, but see how this goes. Questions over homework? I don't know what happened. Which one? What was the problem? Negative 1.5 equals 2 log. So minus 4 is out here. All right, well, you're going to need your calculator for this problem for sure. This is number 23, apparently. Okay, so what we're going to try and do here. Oh yeah, by the way, you see my little voice thing on the side? If you see that not going up and down when I'm talking, please let me know. That means I'm losing the audio. I went through almost my entire Cal 2 lecture on Tuesday and didn't have audio, and that sucks. So, all right, here we go. So the idea here is to try and get the log and everything inside of it by itself, right? That way we can come in and do that loop. So we need to get rid of everything else first on that side of the equation. So I'm going to add 4. That'll be the first thing I do. And that gives me, what? 2.5, right? Equals 2 log 5 minus x. Now I almost have it by itself, except for the 2 in front. So divide by 2. Since that 2 is being multiplied, I'll divide by 2. So divide by 2 on the left. On the left and right. So 2.5 divided by 2 is going to 1.25 equals log 5 minus x. Now the loop that we normally do, usually the log's on the left side. Well, all you have to do is just rewrite the equation. Put your log on the left. It really doesn't matter. When you have an equation, you can always switch sides. Like that doesn't matter. And then you do the loop. But what's the part of the loop that's not shown here? The 10, the base. So remember, log means log base 10. And so 10 raised to that power equals this. So that goes and becomes 10 raised to the 1.25 equals 5 minus x. So on your calculator, 10 raised to the 1.25, 17.78. Is that okay? I'm rounding 2 decimal places now. Equals 5 minus x. Now I'm trying to get x by itself, so let me subtract 5 on both sides. So that gives me 12.78, not 75, equals negative x, right? And then multiply or divide by negative 1. Negative 12.78 equals x. Now, I should point something out here. We have never checked our answers, have we? In everything we've done so far? And that's because we didn't spend a whole lot of time talking about the domain of log functions. But it turns out that you can never, when you have a log, right, any log, doesn't matter what it is, log base b, and you have something inside of it right here, whatever that is, this thing inside can't be less than, well, actually, can't be 0 or less than 0. In other words, it has to be a positive number. Now, I'm not going to ask you to check your answers. But if you're doing problems in the book and they go and they check their answers, they may actually throw out an answer because it doesn't work. Now, this answer would work, all right? The reason why this answer would work is because if you go back to the original problem and plug in negative 12.78 right here, That would go right in here. You'd be doing 5 minus a negative, right? When you subtract a negative, it's the same as adding. So you get 5 plus 12.78. That's a positive number. That's okay. The only time you'd have an issue is if, let's say that this answer down here was not negative 12.78, it was 12.78. Then when you plug it in, 5 minus 12, that's a negative number, and you can't have a negative in a log. So you would actually have no solution if that was the case. And I'm not going to be really focused on that too much. I'm more concerned about you following these steps, doing the algebra, and getting to a result. All right? Sound fair? All right. Any other questions on the homework? 25, is that what you said? 105 and 25? All right, let me do the lower of the two first. So what was 25? Half natural log. Okay. .2. All right, so what would the technique be here? Try and get our log by itself, right? Our natural log. So I will subtract 3 on both sides, which would leave me with 1/2 natural log 2x plus 5. And then when I subtract 3, I should be left with 0.2. You don't have to put a 0 in front of the 0.2. You can just put 0.2. They're both the same thing. And now I need to get rid of the 1/2 in front. So I can either divide both sides by 1/2, or even better, I think, multiply both sides by what? By 2. If I multiply by 2 on both sides, that'll get rid of the 1/2, right? 2 times 1/2 is 1. So those will go away. So I'm left with natural log 2x plus 5 equals 0.4. That okay? Now, can we loop it now? Yes? What's the part of the, yeah, the log? This base is e actually, right? Natural log is log base e. So it's going to be an e like this. So it becomes e raised to the 0.4 is equal to 2x plus 5. Then e to the 0.4 I have to use my calculator for. 1.49 is what I get. So 1.49 equals 2x plus 5. Just stop me if there's something you need me to explain. Subtract 5. When I subtract 5, I get negative 3.51 equals 2x. Divide both sides by 2. Is that 17? Is that right? 17 point something? Negative. Negative. No, never mind. Just ignore me. What is that? I can't think right now. $17. 1.7 is what I meant. 1.76 all round, and it's negative. I think that's a problem. I took too much. I took something last night, and I fell asleep at 6:30 and woke up this morning at 5:30. So I had a good night's sleep, but I still feel pretty bad. What's that? No, I didn't have any weird dreams, though. I never edited that off my video. I just put it out there. You did? All right. I'm incriminated. Does that answer the question that you had on? Are we good on this one? Yeah. Okay. So what was 105? Number 105. 3x minus 2. 128. What? 128.96. Oh, 965, like this. Oh, okay. All right. Well, you have a couple of options here, but if you go off of what I did last class, I said anytime you want to try and solve for an x and your x is in the exponent, you can get that whole thing out if you come in on both sides with a log. And the log that I said we should use is natural log because that's what we have on our calculator. So what I'm going to do is I'm going to take natural log of the left side of the equation. I'm going to take natural log of the right side of the equation. And that allows me to take the 3x minus 2 here, take the entire thing, and drop it out in front of the log. And that's a property of logs. So that's a real nice result. And I still have there the natural log 5, and I have the natural log 128,965. And here's where you would try and solve for x. So you could leave everything in the parentheses here alone and get rid of the natural log of 5 by dividing both sides by natural log 5. You could do that, right? That's what I'm going to choose to do. I'm running out of room, so I'm going to do it up here. I'm going to have my 3x minus 2. When I divide both sides by natural log 5, that's what I have. And now I need my calculator to help figure out what natural log of 128,965 divided by natural log 5 is. Where? You could. Yeah, and then, but what are you going to do with that then? Then distribute it? Is that the way you did it?
I did log in front of it. I did log 5 and then log 5.
Log or natural log? Yeah. Well, if you do log, you still get the same answer, but you had to do log on the right side also.
Yeah, I did.
Okay. So yours looks exactly the same as mine, except you have log 5 here and log over here. 1, 2. Did you do that just because, or did someone tell you use log instead? Okay. That's not the way you did it right there, the way I have it written?
I did log 5, and then I canceled out the log 5, and I had...
Oh, you did log base 5.
Yes.
Okay, got you. All right. Well, let me finish this off this way, and then I'll go back and look at what you did. The way you did it, it would not be wrong. Okay, here we have this. This side is 7.31. Okay, so if you do natural log of 128,965 divided by natural log 5, you get 7.31. Then add 2, 9.31, divide by 3, 3.133, something like that, or something. Is that right? I think that repeats, but anyone get that? 3.133? Oh, 0. 3. 333. So something like that. Yay or nay? Saw you shaking your head, no? You did something. Did you do log 5 also? Log base 5? Through here? Okay, you should still get the same answer. As your final answer? Did you do the natural log on the right side? Did you ever take natural log of 128,9? That's the problem. You've got to do that part. Okay, so Sarah, I'll do it the way you did it, all right? Oh, you got 3.1?
Yeah.
Okay.
I added it. I didn't add the 2.
Yeah. Okay, so I'll just point out that 128,965. I'll point out that you could have done it this way, which is the first way I showed you how to do these, which was to look at the base here, 5, and say, I want to get rid of that 5 so that I can come in with log base 5, and then 5 to the 3x minus 2. Whatever I do the left side, I have to do the right side. On the left side, the log base 5 and 5 cancel. You're left with 3x minus 2. But on the right side, you have to use your change of base formula to figure out what log base 5 of 128.965 is. That's natural log 128.965 over natural log 5. And that's basically the same problem we just had a second ago. So either way will work. All right. What's that? Who? What? I'm not. Mm-hmm. You plugged in your answer? What did you get for your answer? Did you do it a completely different way? Distributed that? Okay, let me figure out what natural log of 5 is real quick. Did you use 1.61? Or what did you use for natural log? So you used 1.609? So you had 3x minus 2, and then you had 1.609. And on the right side, did you take the natural log of all that other stuff? Ooh, that's the problem. That should be 11.77. Try it again. Natural log of 128.965. Did you use natural log or log? One two eight nine six five. Natural log. You got what? Let me see that. One two eight 965. Which one are you hitting? LOG or LN? Try it again. Type in 128.965. Let me see you do it. Clear it. 128.965. Ah, you did 0.965. Is it point? It's not point. Is it 128,000 or is? You know what? You might. Is there a comma in there? It's a comma. Okay, it's a comma. That's what it is. Yeah. Now, so you did it right if that was a decimal. Sorry, Izzy. I'm just trying to help out. Izzy's all upset with me now. Okay. Well, we need to move on and do some more stuff today. So, we kind of left off last time doing problems like this. Log base 2, let's say x plus 1 plus log base 2 of x minus 4 equals 3. This is definitely a test type problem here. Something you see on an exam. So you're trying to solve for x, right? X is the variable. X lives inside of 2 logs. We know that anytime we have an x inside of a log and we're trying to solve, we want to eventually try and use the loop, right? That's been the goal so far. So I need to first put the 2 logs into a single log. So how can you make 2 logs become 1 log? That property, right? It was property 4, wasn't it? Property 4? Property 4 says that you can take that, turn it into log base 2, and then multiply the 2 pieces that were inside each log. So I can do x plus 1 times x minus 4. And then the other side of the equation is still 3. Now, you can expand this or FOIL that out to figure out what this is. So log base 2 x squared minus 3x minus 4 equals 3. Do you agree with that? If you were to expand that and collect like terms, you should get that. And now I can do the loop. So 2 raised to the third should equal that quadratic inside there. What's 2 raised to the third? 8 must equal x squared minus 3x minus 4. This is a quadratic equation. So you have to get it all equal to 0. So move everything to one side. I'll subtract 8, right? Which becomes minus 12. Factor if you can with AC method, but I don't think it's going to work. Quadratic formula. Any questions, though? No questions? So I'm going to say dot, dot, dot. That means I'm not going to work it out. Okay, you would use quadratic formula and solve this. I'll tell you what the answers would be, though. That way you at least have them, all right? Everyone understand what you would have to do at this point, though? Yes? You should get two answers. You should get x is negative 2.27, and the other answer, x is equal to 5.27. I encourage you to go do that, finish that problem on your own. Make sure you can solve that using quadratic formula. And in case you've forgotten what it is, that's how you find the solutions to a quadratic that looks like that, right? You have ax squared plus bx plus c equals 0. The solutions are x equals negative b plus or minus all that stuff. You've done all that. We've done that. We're happy with that? Okay. All right, I'm going to move on. How about this? Log base 2 x plus 3 minus log base 2 x plus 4 equals 4. Yeah, the only difference really in this problem is the subtraction instead of the addition, right? You need to pay attention to that on the test. You don't want to always say, oh, okay, every time I see two logs, I'm just putting them together in multiplication. No. If it's addition in between, you put them together with multiplication. If it's subtraction, you do division. So this is going to become a single log. By the way, this is property 5. Single log, it'll be the x plus 3 on top. It'll be the x plus 4 on the bottom. Oh, I forgot my base 2, log base 2, equals 4. And now I can do the loop. The loop will be 2 raised to the 4 equals this. So 16 equals x plus 3 over x plus 4. Any questions? Now, it's been a while since you've seen an equation like this. Like the last equation we did was quadratic, right? And we've done linear equations also, but this is a rational equation. You took 0303 and 0302, you looked at these at some point. To solve a rational equation, you look at the LCD, least common denominator, and you multiply both sides by the LCD. Well, the only denominator we have is x plus 4. So we multiply both sides by x plus 4. So I'm going to multiply the left and right sides by x plus 4. And we do that because on the right side, the x plus 4 cancels with the x plus 4. The other side, you have to distribute that 16 through. So you get 16x plus 4 times 16, 64, must equal x plus 3. And that is a linear equation, right? It's a linear equation. So you just get all your x's on one side, all your numbers on the other. So how about subtracting an x from each side? How about getting that 64 out of there by subtracting the 64? We are left with 15x equals negative 61. Man, I'm hungry. I don't think I ate dinner last night. I just went to bed. Okay, what's our answer here? X is negative 61 over 15, whatever that is. You can get it as a decimal or you can leave it as a fraction. Doesn't matter to me. I'm just going to box it. Okay, Now, technically, again, I want to point this out. Technically, let's see if this answer would actually work. This comes out to be about negative 4.07. Would that work if I tried plugging it in? Look at this right here. If I plug it in right there for that first x, what's negative 4.07 plus 3? It's a negative number, isn't it? You can't have a negative inside of a log. So this solution actually doesn't work. So that means that technically there is no solution to this equation. But I'm not going to ask you to check. I want to see negative 4.07. Now, if this was Math 1414, you're all going to be engineers. You're going to be building bridges one day. We'd be checking all our answers, always. Okay? Pardon me? No, I don't know. I don't know what I'm craving. It's something, but what kind of donut is it? Pink icing? No, I'll pass. Thank you, though. What's on the inside? Nothing? Just a regular old donut? I like those Bavarian cream donuts. I'm going to eat the bag, too. All right, so any questions on that? If we have two logs with addition or subtraction, we see that we can kind of resolve the issue here. All right, let's look at another type. How about if we have something like this? Log base 5 x plus log base 5 x minus 2 equals log base 5 7. They're all 5s, sorry. And my 5s and s's do kind of look like. I need to work on that. And I don't really have a good way of distinguishing those. I am. I heard today on the news that you increase your chances of liver disease if you're drinking. Thank you. If you're drinking alcohol while you're taking acetaminophen, which is like Tylenol. Anyway, just FYI, you're not supposed to drink while you're on medication anyway, but I'm just saying, I heard it on the news this morning. It's like really bad for you. FYI. So take ibuprofen instead while you're drinking. Yeah. My wife used to work at Lackland, so she knew a lot of the airmen, you know, like right into the Air Force, those airmen. And they would, a lot of them very young, they're partying a lot, and they would have friends that were like medics. And so what they do is they go out and they drink, and then that night before they go to bed, they do an IV. They rehydrate. It works. I mean, I've never done it, but I mean, that's, your body needs fluids, right? That's why you're hungover. So, okay, hey, look, we need to get back on topic here. I'm sorry. What's the difference between this and what we've seen before? There's something very different. There's 3 logs, okay? Everything we've seen up to this point, we didn't have another log on the other side. Now that's going to cause some issues. Let's see what it does. If I try and put the 2 logs on the left side together, that's addition. Addition becomes multiplication. So I already multiplied those 2 together. Is that all right? I kind of skipped that step, did it all at one time. X times x minus 2, distribute the x, equals log base 5 7. Now, if you try and do your loop right now, it's going to be weird because you're going to have 5 raised to the log, all that stuff equals this, right? But we also had a property, I believe it was property, was it 8? Was it 7? No, when it was log on the left side, log on the right side, the insides had to be the same. Was that 7? I'm going to go back and see. Yeah, 7. There it is. See 7? If we have that right there, look how good my handwriting was that day. If I have that, then I can just set the insides equal to each other. And that's what we're going to use. Oh. What am I doing? I'm lost. Hold on. I'm lost in my own notes here. I thought I was in this section. I don't know where I am. I really am lost. Come on, we were in week 11, right? Does anybody know where I am? My notes here? Well, it saves automatically, but for something that says simple interest. Wow, how'd I get out there? That needs to be down in week 11. There. I found it. Sorry, we're back to work now. All right, so here we go. I'm gonna forget the loop, and I'm gonna say I have log of something equals log of something else, right? And therefore, by property 7, I just set those two equal to each other. And what type of equation is that? Quadratic. Move everything to one side, and then solve. And your solutions, without me actually going through it, are going to be x is negative 1.83 and x is 3.83. I would use quadratic formula on that. That's what I would have done. You would have been forced to do that because you can't factor that. Yes, it is possible. Yep. I think, though, if you try and plug in the negative one here, it wouldn't have worked because it wouldn't have worked in that first one. But again, I'm not going to ask you. I just want those two answers. Mm-hmm. All right. I think I'm officially done with, well, we're done with exponential and log as far as, I have to be careful, as far as the solving equations and the graphs and stuff like that. We have one more thing to do with exponentials and logs that involves, it's like an application, okay? It's just how could we use this in the real world somewhere? And we're going to do it with interest, like simple interest. So that'll be our last sort of topic. And then I don't know what we're going to do after that. Take the rest of the semester off? What do we do? Let me see. When is our test? Let's see here. Thursday, next Thursday. Hey, we're actually on track. Wow, I don't know how that happened. Okay, 4.5. We're going to start it today. We'll finish it up on Tuesday. And we'll do a review next Tuesday and plan for the exam. Let me try and send out a review for you, okay, this weekend. Give me a moment to remind myself to do that. Well, where's my phone? There it is. How much time do we have left? Oh, we still have plenty of time. Okay. All right. Here we go. Let me start this. Applications. There's lots of applications of exponential and log functions. I'm going to focus on finance, specifically what's called simple interest. What is interest? Yeah, like okay, so you have a credit card or something like that. You have an interest rate, right? How many of you have a credit card? Maybe that's not my business, huh? You don't have to, or you pay interest or something like that on a mortgage, right? How about if you? How many of you put money into a savings or checking account? Okay, you can look at interest two ways. All right. One way is if I have money, let's say I have some money, right? And I want to put it in the bank. The bank will say, "Okay, Robert, here, let me take your money, and to have your money, I will give you a little bit of money. Every month I'll give you a little bit of money just because you want me to hold on to your money. I'll pay you for it." Well, then Mr. Lee comes over here. He's like, "I need money." Is that surprising? Uh, hey, you want to talk? I'll include you in the example. Okay, so he comes to the bank and says, "I need money," right? And I say, "Sure. Here's some money. Here's some of Robert's money, and I'm giving Robert like nothing for his money, like 1% of what he gives me. I'm going to give him back every month, and then you're going to borrow it from me, but you're going to have to pay it back at like 20% or 10%, right? And that's the way the bank makes money. They're making money off of other people's money, right? That's the way the bank works. So if you owe somebody, if you owe the bank or you owe a credit card or something like that, you're basically paying someone to borrow their money. Not that it's not even the bank's money, it's someone else's money. Right? That makes sense? So it's always a higher interest rate if you borrow than if you give your money to someone. Because someone's got to make money in that. Right? The bank can't give me 20% and then ask someone else, "Hey, here it is, but you only owe 10% back." Okay, so how does the bank compute the interest? All right, there are two ways, and that's what we're going to discuss today. So the first way that the bank computes interest is using this formula right here. A equals P times 1 plus R over N raised to the NT. I almost forgot it. Now let me explain everything in this formula because there's a bunch of letters in here. I'm going to explain what each of these pieces are. We'll start with P. P is called the principal. And that's the amount you start with. And in other words, that you borrow or put in. So that means that the principal is the amount that I would say, okay, I go to the bank and say, "Hey, I need to borrow $200,000 to buy a house," right? $200,000 is the principal. Yep, that you start with, okay? Or you go to the bank and say, "Hey, I have $10,000 that I want to put in here." That's your principal. Okay, that's your starting amount. Got it? R in the problem is the interest rate. And you always need this to be a decimal. So it needs to be a decimal in the formula. Do not forget that. So if the interest rate, I'm going to put an example underneath this. If the interest rate is 3%, then it's going to be 0.03 in the formula. You remember how to convert decimals to percentages back and forth? You just move the decimal point 2 places, right? So what would 100% be? What would 100% be? I take the decimal point, which is right after the 100, I move it 2 places to the left. So it would be a 1. 100% is 1. Okay? Don't forget that. That's what R is in the formula. And then let me do T next. T is the time in years. And this is basically the time you leave it in the bank. Or how long you have to pay it off. It's always measured in years, though. So let's stick with the example of I'm going to go put some money in the bank. Okay, I'm going to put some money in the bank, and I'm going to put it in there. I'm going to leave it in there for 5 years. I'm not going to touch it. I'm just going to put it in there in a savings account and let it grow off of the interest. All right, the time would be 5. If it's 5 years, 5. Or if you do a mortgage and you borrow $200,000 and you 30-year mortgage, then T would be 30. Now, if it's a 6-month, you're leaving it for 6 months, then what would time be? 0.5, half a year. So you have to pay attention to that. And then N is the weird one. It's the one I've kind of saved towards the end here. N is the number of times the interest is what they call compounded per year. This is a confusing number. All right, let me try and explain without getting too technical. Let's say that I put in $10,000 into a bank. All right, $10,000. And they give me 5% interest. Okay? Yeah, that would be good. $10,000, 5% interest. And they compound the interest one time a year. How much money do you think I should have? What's 5% of 10,000? So do 0.05 times 10,000. What would you get? 500, right? So I should have $10,500. That's 5% once a year. That's what I would have at the end of 1 year, right? I'll put this, I'll write on table. I think I need it on a new page, though, just so I don't mix it up with this. If I start out with $10,000 at 5% for 1 year, then what will happen is after 1 year, I'll have $10,500. Does that make sense? Now, if I leave it in there for another year, how much will I have? Well, they're going to give me 5% of 10,500 now because I have more money in there. You see? So now you need to do, 5% times 10,500. So you're going to get $525. So 11,000 to 25. Does that make sense or not? And now if I go another year, they're going to give me 5% of that. So it starts to grow, right? That's the idea of compounding once a year. But what if they compound it monthly instead? That sounds like a way better deal, doesn't it? But it's not necessarily a better deal. Because if they do it once a month, here's what they're doing. Instead of taking $10,000 at 5% monthly, let me put monthly here. Instead of saying, all right, I'm going to take your $10,000 and give you 5% after the first month, and then after the second month, do it again and do it again. My money would blow up in the bank. I would be a millionaire very quickly, right? What they do is they divide the 5% by 12, and they divide the money by 12. And that's how much. So it's still a little better than once a year, but it's not significant. It's like pennies. Okay, so so if a bank is like, we'll compound the interest once a year, versus monthly. Usually monthly is better for you, but not like big time. Or they'll say they compound it daily, which means they do it 365 times a year or something like that. That's a little better than monthly, but still not enough for you to make like, you shouldn't base your decision on that. Okay? That's just to give you an idea of what that number means. Back to the formula. The final thing in the formula was the A. The amount, the A is the amount left, or the amount that you owe after the T years is up. So the left side of that equation is just how much you either owe or how much you're going to have sitting there waiting for you if you left it as a savings account. All right? Now, let me go back up and show you something on this formula here. Notice in this formula that if I asked you to solve this formula for t, where is t in the formula? In the exponent, right? So in order to solve for t, if I ever ask you to solve for t, you're going to have to try and get that t down, which means you're going to have a log, right? Do you agree? And a lot of times we want to say, hey, look, I want to take $10,000, put it in a bank, right? And they tell me their rate's going to be a certain percent, and I want to know how long it's going to take before that money grows to be a certain amount. That means a lot of times I know how much I want to put in, right? I know the bank's interest rate. I know how many times they compound it. They tell me that. And I know how much I want to have at the end. And the question is, how long does it have to sit there? So we want to know what time is a lot of the time. So we need to be able to solve it, like use a log, right? Okay, so let's do it. Let's do a problem. Where? It's a 1. It's a 1. All right, here we go. First example. You wish to invest $5,000 into a simple interest account at 1.3% and determine how long it will take to double. If interest is compounded monthly, how long will it take? What do you think? It's going to be a while? You want to double your money. Turn $5,000 into $10,000, right? You've got a 1.3% interest rate. How long is it going to take to do that? And again, you're going to leave the money in there. You're not going to touch it. You're just going to let it sit there. Okay, ready? Let's write down the formula. A equals P 1 plus R over N raised to the NT. Let's write down the things that we know. Do we know P? What's P? P is how much we're going to put in. Do we know R? .013, right? 0.013. That's 1.3%, moving the decimal 2 places to the left. Do we know t? No, but that's what we want to know, right? T's the question here. Do we know n? How many times it's compounded per year? What is it? Monthly? So 12 months in 1 year? Do we know a? How much do we want at the end of it all? 10,000. So what we're going to do is we're going to rewrite the entire equation out with all those things plugged in. And the only thing we won't have is t, right? So this will become 10,000 equals 5,000 times 1 plus 0.013 divided by 12, all raised to the 12t. Everyone see where all that came from? Now, before we try and solve for t, let's clean some stuff up. If you could, get on your calculator and do 0.013 divided by 12. Now, what we're going to do now, because this is a finance problem and because it matters more, we're going to go as many decimals as your calculator goes. So if it goes 8 or 10 places, take them all right? You have 333? Okay. 10? The more you go, the more accurate it is. Now, I will always keep that in mind when I'm looking at your work on a test. 10,000 equals 5,000. Now, you can kind of skip a step here because whatever you get there in the yellow, you're going to add it to 1, right? So if you got like I got 0.001083, I add that to 1, it's going to become 1.001083. You follow me? Okay, so go ahead and put it all together. I'm 1.001083. That's how far my calculator went. All right, so that's where I'm stopping. And then raise to the what? 12t. Questions? Pardon me? Raise to the 12. No, you can't raise that to the 12 because you don't know what t is. So look at this. This is very much like a problem where we have something, right? A base raised to a power. And so to get that power 12t out, we need a natural log on both sides, right? Remember, to drop the power out? But you can't take the natural log until the base is by itself. Right now we have a 5,000 in front. So how do you get rid of the 5,000? Divide by 5,000 both sides. So divide 5,000 here. Divide by 5,000 here. 10,000 divided by 5,000 is what? 2. Division. Then 1.001083 to the 12t. Now can we come in with the natural log on both sides? Now, do you see why we would not want to use that old technique? Remember the old technique? You would look at the base and you would say, okay, that's the log I'm going to come in with. Like if that was a 5 to the 12t, you would come with log base 5. Now our base is something crazy. So it's better just to use the natural log on both sides. So that's what I'm going to do. Natural log of 2 equals natural log on the other side, natural log of 1.001083 to the 12t. And because of that, the 12t can drop in front of the natural log. And that was the whole point, is to get that 12t out. Questions? So we have natural log 2 equals 12t times natural log of 1.001083. And remember, I'm trying to get t, right? So how am I going to get t? You're going to have to figure out what natural log of 2 is on the left side, right? You're going to figure out what natural log of 1.001083 is. All that. You're going to divide both sides by 12 and that natural log. So let me divide both sides by 12 first. I'm going to take natural log of 2 on the left side, on my calculator, natural log of 2, and divide it by 12. And I get 0.057762 equals t, and I still had that natural log of 1.001083. Now I'm going to divide both sides by that natural log. So take that answer I just got, 0.057762, divide by natural log of 1.001083. This should be my final answer here. Oh, not happy. 53.3641 equals t. You should be getting something close to 53. That is a long time. Because in 50 years, $5,000, right, after inflation, isn't even going to be worth $10,000, you know? It'll probably be like a gallon of gas, right? $10,000 a gallon. What? Yes? I did this right here. I divided by natural log of 1.00. It goes away over here, but then I take that and divide it by natural log of 1.001083. And that's how I got to 53. I did do the natural log on my calculator. Or did you not get 53? Okay, take that number and divide both sides by that number. So take your 0.057762, divide it by that answer. Okay, what do you think? This is called, a lot of times in finance, this is called the doubling time. You know, it's the amount of time to double your money. What will affect it is your interest rate, right? Your interest rate will affect how fast it doubles, how long it takes, and the number of times it's compounded. Now, because we're almost out of time, I just want to show you one last thing. This is really more of just an interesting result than anything else. Let's take this same formula. Anybody watch World Series of Poker? No? Okay, I'm not a huge fan of like poker or anything like that, but there was a they have this tournament every year where everyone like pays a certain amount to get in this tournament, and then the winner, you know, whoever's the last one standing wins. And the winner this year won $8.5 million, right? And after taxes, they'll probably see about 4 million of that. So let's just act like you won the lottery or something, and you just all of a sudden came upon $4 million. I'd like to put that into a bank account, okay? That, well, you can't, but let's just say you invest it into things that are going to return to you 3%, which, you know, I think that's a modest sort of investment to expect 3% back. Okay, let's just see what happens after a year. If it's compounded, we'll say monthly again. So, lotto winner puts in $4 million into account at 3% compounded monthly. How much is there after 1 year? So this problem is a little different because I'm not actually asking you to find how long it takes. So normally I wouldn't ask something like this on a test, but I just want to show you something here. So how much is being put in to start? 4 million, right? P. What's the interest rate? 0.03, right? What's the time? 1 year. See where I'm getting all that from? Okay, the amount is what we want to know, right? How much is going to be in there? That's the amount. That's what we want to know. Monthly is 12. Yes, thank you. This right here, monthly, that's my N, and it's 12. Get all that from the word problem? We're almost done, Izzy. So the amount, A, will be equal to 4 million 1 plus 0.03 over 12 raised to the 12 times 1. Does everyone see where all that came from? You could be putting raised to the 12. I just want to make sure everyone sees where all those pieces are coming from. So A times 1 plus R over N, all raised to the NT. Go ahead and do the 0.03 divided by 12. So this becomes 4 million. And then 1.0025 raised to the 12. You have to do order of operations here. So exponents comes before the multiplication. So you don't multiply the 4 million times that number first. You raise it to the 12. 1.0025 raised to the 12. So 4 million. Oh, Izzy, come on, buddy. 3042. You following still? Raise that to the 12. Now multiply times 4 million. And you should get 412,166 something like that. And then you might have some decimals, but let's just say approximately that much. Let me make that a little bigger. 4. What's that? So what does that tell you? After 1 year, how much money does this person earn in 1 year? $121,000 for just sitting on the money. But using this computation, if you had $4 million sitting in the bank and it was returning to you about 3%, now you wouldn't have it in a bank. You invested in the stock market or something like that. With even a modest 3% return, you could almost live off your money. Live off of it, right? You could, I mean, yeah, you wouldn't be out with, your Lamborghini and things like that. And that's just for a year, right? So, I mean, think about if you want to be my neighbor's a doctor, probably makes 160, 170,000 a year. I mean, this is almost doctor level just for sitting on your money. You don't have to work. So you work just a job on top of that, right? And that's why they say, the rich get richer. I mean, imagine Oprah, right? Sitting on billions of dollars. Bill Gates, billions of dollars. I mean, those people, if you do a computation on, imagine if this was, instead of 4 million, 40 million. The only thing that would have changed is that would have become, instead of 121, it would have been $1.2 million. So if you have 40 million in the bank, you make 1.2 million a year. Does that make sense? You have 400 million, you're going to make 12 million a year. It's pretty crazy. Think of it that way. But all right, well, Let me email you some stuff. Like I said, the review. Let me email you a review for the test, and we'll start working on that on Tuesday. All right? I guess now I can say have a good weekend.